So to launch our discussion of matrices, we're just going to piggyback off of the last question from your homework, which was on the peanuts and the cashews. Okay, the hardest part is going to be writing the system on your own from a word problem. Okay, I recognize that. I know that's going to be difficult. It comes with practice of you being able to write a system. Once you have the system, it is a breeze to turn it into a matrix and to have the calculator solve it for you. All right, so I know that this is going to be hard for you to write the systems. If you're having trouble, tutoring on Tuesdays, come on in and help. Let me help you out with writing these. Okay, in order to use matrices, there has to be a coefficient, a number, in front of every variable. So it's going to be your job to go back and add the number ones in front of the variables. You can't have, don't tell me nothing is there. Okay, something is there. All right, how many variables are there? Different variables. There are 2. All right, so this is called a 2-variable system, which means you're going to have a 2-by-2 matrix. Okay, if you remember from Algebra 2, a matrix is written with a bracket like that. And this is going to be a 2-by-2 matrix where you just focus on the numbers. So the number 1 and the number 1 are the top 2 numbers because that comes out of the left side of the system. And then 2.38 and 6.37 are the bottom 2 numbers of the system, of the matrix, because they come out of the system. So this is called a 2-by-2 because it's 2 rows and 2 columns. So it's a 2-by-2. Next to that, you put a single matrix of P and C. And it's written in a column, not in a row. Okay, you just need it once. You don't need a P and a C and a P and a C. You just need P and C once because we only have one set of variables. And then after the equal sign, you again have a column, and that's going to be the 5, and it's going to be the 19.60. So that's how you turn a system into a matrix. You'll always have a 2-by-2 or a square matrix, a 3-by-3, followed by a variable matrix, and then a constant matrix on the outside. Once you have it written, is there any questions about writing a matrix? Okay, once P came first. All right, so then what we want to do is we want to get this matrix alone. Okay, we want to get that matrix alone. We're going to call this matrix matrix A, and we call this matrix matrix B. And we want to get the variable matrix with the variables in it, the P and the C for peanuts and cashews. We want to get that by itself. So how can I get rid of the A matrix over on the left-hand side? I don't know if you remember this from Algebra 2, and get it over to the other side. Whoa, okay. Okay, we're going to use inverses, exactly. All right, in order to take this matrix and move it to the other side so that we can have the variable matrix alone, we use the inverse matrix. And so what you'll have is you'll have then P and C by itself, and you would have A on this side next to B on this side, but the A is what's called an inverse, and we use the little -1 as a symbol. The inverse has to be written there, and it has to go in front of the B matrix. Otherwise, you'll get error on your calculator. All right, so to move one matrix from one side to the other, it becomes an inverse on the opposite side, which is true in all math. If it's adding on one side, it's subtracting on the other. If it's multiplying on one side, it's dividing on the other. It's always inverses when you move it from one side to the other. All right, now's when you need to grab your calculator so we can learn how to do this, or remember how to do this on our calculator. All right, most people, hopefully everybody got the following results. 3.07 and 1.93. Okay, what does that mean? What is the meaning? 3.07 peanuts? That's it? Give me, hello sir, I would like 3.07 peanuts, please. Okay? No, it does not have, we already know how much it costs per pound. We already went through that. We were given how much it costs per pound. Okay? How many pounds? That's how many pounds I want. So I have, the meaning of this is 3.07 pounds of peanuts, not just peanuts themselves, but the pounds. and then 1.93 pounds of cashews for a grand total of how much? 5 pounds, which is what we knew we were supposed to have for starters anyway, okay? If your answer didn't add up to 5, we'd be in trouble. Okay, so that's a way to use a system and solve it with matrices. Okay, let's try another one. All right, here's your next system. Ready? 3x plus 7y minus 11z equals 44. All right, how many variables? 3. So we are going to need how many total equations? 3. You can't solve a system unless you have at least the same number of equations as you do variables. You can have more, but you can't have fewer. All right, you have to have at least the same number. All right, so 3, 7, negative 11 equals 44. X plus 2y minus 3z equals 12. And 4x plus 9y minus 13z equals 53. All right, your job before you make this into a matrix is you got to make sure all the numbers are there. All right, so what number is not there that I need to add? Okay, what about the x? It needs a 1. All right, so let me ask you a hypothetical question. I'm going to erase something. I just did. What if there was a part missing? Okay, you have to put 0 in to hold the place, because you need, if you're going to make a matrix, what size matrix would this be now? 3 by 3, which means how many total entries are there in a 3 by 3? There's 9. You got to have 9 numbers. So you have to have a 0 there if you're missing a number. Okay, don't just like leave it blank. You have to have a 0 there. All right, I'm going to go back to what it really was. Okay. All right, now we're ready to make our 3 by 3 matrix. And so our numbers across the top will be 3, 7, negative 11, followed by 1, 2, negative 3, followed by 4, 9, negative 13. The variables would be an x, y, z variable matrix, so 3 of them in a row, and the constant matrix would be 44, 12, and 53. So now you're going to put that matrix, change the size in your calculator to be a 3 by 3, and do the exact same A inverse times B. Okay, so we end up with negative 1, 2, negative 3. All right, what does that mean? Okay, but what does it mean? Last time we were talking about peanuts and cashews. What does this represent? If this is not a word problem, then what does that represent?
It's just the solutions actually equals -1. The coordinates, right?
Okay, it's the coordinates. Is it possible to have a -1, a 2, and a -3?
Yeah.
What does that mean?
That means the plane the point.
3-dimensional. Okay,
Yeah,
very good. This is a 3-dimensional solution. Okay, so now for those of you who are thinking about going into design, graphic design, interior design, architectural design, any of those design things, you'll be working in 3-dimensional space. So this would be a solution in 3-dimensional space. Okay, next example. Now, when it's just a straight out system, it's pretty easy to solve with a matrix. It's hard when you have to write the system yourself from a word problem. So we're going to practice that next, writing a system from a word problem. I usually recommend, they'll give you a whole paragraph. Like some of these questions are going to be like this long and it's all words. Take one sentence at a time, okay? Take one sentence at a time. Don't mix units. Look for the units throughout the problem and make sure that whatever you're writing, you're only using numbers from that unit. All right, here's an example. Okay, Oscar invests $20,000 in 3 accounts. There's a period, which means I should be able to write a math expression from that. So I'm not going to do the whole paragraph at once. We're just going to look at one after the other. Okay, anybody want to take a stab at writing this? Danny?
A plus B plus C equals.
All right, perfect. All right, A plus B plus C equals $20,000. Now, do we know how much is in A? And how much, I mean, is it like $19,998 in A and then $1 in each of the other 2 accounts? I mean, we don't know how it's not, and is it split evenly or is it not split evenly? We don't know. He could have used X, Y, and Z. He could have used PDQ. I don't care. All right, whatever variables we've got. All right, next sentence. So kind of look at them sentence by sentence and see if you can translate that into math. The next part. The interest is $1,780 earned at 6%, 8%, and 10%. All right, period. So I should be able to write a sentence from that. Does anybody want to take a stab at that one?
Equal to 17.
Okay, it's going to be equal to 1780, all right?
6A, no.
6A,
And then 8B,
8B,
plus 10C
10C.
equals 1780.
All right, what do we think? Oh, it's
I agree, Grace. I agree.
it's close. It's close. All right, way to put yourself out there. All right, 6%. Okay, 6% as a percentage, when we need to turn it into the appropriate decimal. So this is going to be 0.06, 0.08, and 0.1 other. Okay?
It's pretty common.
All right, so, but again, you know, we've got an equal to our total, and then we make sure that with interest we're using percentages. Okay. If we've got 3 variables, what do we need in our system at least? At least 3 equations, maybe more, but at least 3 equations. In the last account, Oscar puts $7,000 more than the other 2 combined. All right, so we've had Danny do one, Greg do another. Okay, let's see if we can get our last part of our system out of here. In the last account, Oscar puts $7,000 more than the other 2 combined. Go ahead, Tess.
Is it A plus B equals 7,000 C?
Okay, so there's the other 2 combined. And then she said equals 7,000 C, so she's trying to get the more than part going on there. She's pretty close, but that's not quite right. All right, so the A plus B is good for combining the other 2. All right, anybody want to try amending that a little bit?
Can I amend it?
Yeah.
Is it 7,000 plus C?
Nope.
Oh. Oh.
Okay,
Is it A plus B plus 7,000 equals C?
there you go. All right, A plus B combined plus the 7,000, that's going to be equal to the C. Okay, A plus B, that's the combination of the first 2, and then $7,000 more than that, and then that would be equal to the last one. Okay, when we make our matrix for this, we have to make sure that all the A's and the B's and the C's are on the same side of the equation. So right now, the way we have it, what she's written is correct, but we need to modify the order so that we've got all the A's and the B's and the C's on the same side. Okay, so I'm going to keep that A here that B, but then I'm going to make minus C so that I can have the C on that side. And what do I do with the 7,000? Not, it needs to be negative 7,000 because I have to subtract it to the other side. And what needs to go in front of all those letters? Ones. All right, so now we're ready to make our system. Okay, what's the top row of the system? 1, 1, 1. What's the second row of the system? 0.06, 0.08, 0.10. And then the last row of the system, 1, 1, and negative 1. Okay, and then our system, our matrix would be A, B, and C. And then the last part of the matrix would have what as my top number? 20,000. What is my second number? 1780. And my last number? Negative 7,000. All right, go ahead and put that 3 by 3 matrix into your calculator. You should get, if you've done everything correctly, everything should end in zeros for your answers. Your answers should come out to be nice whole numbers. So using A, B, C as inverse in your or A and B matrix and inverse in your calculator, see if you can figure it out. Make sure the answers add up to 20,000, but they will also, all end in zeros. All right, so we end up with 4,500, 2,000, and 13,500.